All right, hi everybody, and welcome to this episode of iBTV. My name is Kelly, and today's topic is 5G. I'm here with Zach from our products team, and he is helping iBwave lead the way in introducing our 5G capabilities. So we're here to talk about 5G, Zach. Welcome to the show.
Thank you.
So Zach, why don't you just start by giving us an introduction to 5G and tell us, what is up with 5G? And what's it really trying to achieve?
Sure, it's a good question. What is up with 5G? Well, 5G is one of those things which is next evolution technology, and it's really trying to address three major problems, which right now we are kind of facing, but the market's starting to push for because it makes sense. Problem number one is, how do we get more data to people, more data and faster? That's typical for any new technology. And there's two other problems which are interesting. Number one is IoT. When you look at IoT, you have to connect a lot more devices. There's now smart everything and smart cars even. So that's a lot more things that are going to be connected and will cause congestion in regular networks, and 5G tries to address that. And then the last item is latency. So this is one of those things that most people don't notice. If you're a gamer, you'll notice. But in a lot of applications now, robotics in a factory, remote surgery, smart cars, you have to have low latency. Low latency means that, well, when one car says there's been an accident, you don't have to wait 20 milliseconds for the other cars to realize it, because by then, well, you've crashed yourself. So you need this kind of thing to happen in these networks to, facilitate all those things. And that's what 5G is really trying to address.
Makes sense. So a lot of the use cases I've heard, for example, the driverless cars that you just mentioned, they tend to be outdoors. So can you talk about specifically what's it going to mean for in building?
Sure. So in building, it's pretty much the same story. The latency aspect will probably take place in maybe car manufacturing or an Amazon type of factory where you have robots being more automated, going and doing deliveries, and having a latency reduction in those situations is pretty beneficial. But otherwise, in an office is what you would want. Video conferencing is increasing, so you need more data. More people are going around with their mobile phones, and you want to facilitate that without ruining anything in the work environment. But yeah, people are using more videos, they're communicating online more, and you'll need more data. And with everything else, smart watches and so on, just them walking into your office, they should be able to connect just like anything else. So again, it really does work in building as well.
Makes sense. And so we're kind of in this transition of starting to go from 4G to 5G, but it makes me think about the time when we transitioned from 3G to 4G. Can you talk a little bit about, I guess, what the differences is between those two transitions? Is this kind of a bigger effort that it's going to take than 3G to 4G, or what's the difference?
Yeah, there's going to be some changes there. The evolutionary step between 3G and 4G in the later years when LTE was being ratified, a lot of the hardware being sold at that point for outdoors and indoors, some of it was compatible with LTE, that just wasn't enabled. A lot of manufacturers were promising a firmware update, and in a lot of cases that's what ended up happening. When people finally turned the switch and enabled LTE, it was, company A said, or some operator said, let's do it, and they did a firmware upgrade, did some testing, and then it was rolled out. But in 5G, when you're talking about an entirely new frequency spectrum, because 5G is not just the same sub-6 gigahertz that we were talking about in LTE and in 3G. It's also millimeter waves. In that case, there's a lot of hardware changes. Antenna arrays are much bigger. There's a lot more antennas. There's the concept of beamforming that takes into place. There's even on the indoor scale, you have to worry about a lot of different things as well. The same kind of problems, but at the same time, the DAS model is pretty much done. Doesn't mean there won't be a new upcoming product that will address that same kind of issue, but it means that for the most part, coax cables are gone. You have to have fiber, which means that you really need to start worrying about how you're going to build that infrastructure to support fiber in your building.
So I imagine not a lot of buildings have that infrastructure in place right now.
Well, newer ones might, but the old ones not so much.
Makes sense. Makes sense. So then I guess in summary, what would you say are the really key benefits of 5G that we're hoping to see
primarily, I mean, without a doubt, it's always speed increases.
Speed. It's all about the data and
It's
speed.
all about data. It's all about high definition data. It's all about facilitating new technologies. We've been hearing about AR. We've been hearing about VR. A lot of those things are limited by speed and latency. And this is something that's being addressed. Now, you could do that if you were fixed into a wall with a cable, but the world is wireless now. So this is one of those things that really helps
wants
with
to
that.
remain wireless.
Yeah.
All right. So I know you have actually an example that can show us the difference that 5G is potentially going to bring. I think this is like a small cells.
Yeah, this is a small
example?
cell example. And so what this is if you look at the actual screen, you'll notice that there's a bunch of small cells around. But that's sort of misleading. Let's take a look at just this one section here.
Okay.
In this area here, I actually have two small cells, one on top of the other.
Okay.
One is operating at 700 megahertz, which is a general everyday frequency people are used to.
Yeah.
And the rest is operating at 28 gigahertz, which is that millimeter wave spectrum. So here in this office, you have the usual walls, buildings, cubicle spaces, and so on. And what I'm showing is what the signal strength coverage is at 700 megahertz at this point.
Okay, so that's what it would be today with how everything is.
Everything's
right
got a nice warm glow. Everyone's covered in enough to be able to operate their equipment. But look what happens when I switch to 28 gigahertz. All right,
Okay.
now I've enabled the rest of the small cells.
Right.
Because in that same spot, you're kind of getting the same coverage overall, but it's not as warm as before. And everywhere else, everything that you see, all the walls are much more severely attenuating the signal. You're getting a lot more blockages. You can see the direct line here where it feels very much like a beam of light escaping this window.
Yeah.
So in these situations, you can tell right away that when you talk millimeter wave, the deployment is much heavier. You have to have a lot more cells, you have to have a lot more fiber, and it has to be a lot more connected. And once you do that, then you can really enable 5G at the millimeter wave. If you wanted to do 5G at the sub-6, it's still at that 700 megahertz level, well then you'll get this coverage again, which is great, but you won't benefit from the vastly improved speeds.
Okay.
There you have it.
That's it. All right. Well, thank you for being here with us today and talking to us a little bit about 5G and showing us this example. To everybody watching, we hope you enjoyed our recap of 5G and meeting Zach here. Thank you for having us.
Not a problem.
And thanks everybody for joining, and see you next episode.
See you then.